Hi everyone, welcome back to Spratt STEM Academy. This is problem 3 in my series of balancing chemical equations. So here we have an unbalanced reaction. I've saved us a little bit of time and already wrote out my lists of elements on both sides just so that I can just get straight to counting how much of each element I have on both sides. So let's start with the left side, the reactants. We'll start with H. Now in this, there's an H present in this compound, but there's also an H present in this compound. So don't let that confuse you and only write that there's one H. It's important to look at everything that you have on the left side. So rather than saying we have one H, we actually have three H's. And let me explain this a little bit more. If you look at this OH in parentheses with a 2 outside of it, all this is saying is that we have this subscript 2 on this O and H together. So this 2 is being multiplied to this O and this H that are in the parentheses. So if we have one H here in this HBr and two H's here in this OH, that means in total we have three H's on the left side, okay? So I'm going to erase these now, and hopefully that makes sense. So now let's move on to our Br. We see that we only have one Br. There's no Br in this compound, and the Br doesn't have a subscript anywhere, so we just assume that there's one. Our Mg, there's no other Mg on the left side except for right here, and it doesn't have a subscript, so we also just assume that that is 1. And then lastly, for our O, same thing as when we were looking at our H's. There's no other O anywhere except for in this little compound right here. And the 2 on the outside of the parenthesis is being multiplied into that O. So we do have 2 O's. So we're done with the left side. Let's look at the right side. For our H, we have 2 H's. And we know this because I see an H here and it has a subscript of 2. So I'm going to write there are 2 H's. For our Br, we see Br here, and it has a subscript of 2, which means there are 2 Brs. Let's look at our Mgs. There's one Mg here, and there's no subscript, so there's just 1. And then for our O, there's one O right here, no subscript, so there's just 1. Now, let's look at how to balance this. If you look at our left and right elements, like here, we see that most of the numbers are not the same. For example, we have 3 hydrogens on the left and 2 hydrogens on the right, 1 Br on the left, 2 Brs on the left, and so on. So our task is to balance those together. Let's start with oxygens because it's a lot easier to go from 1 to 2 than it is from 2 to 3. So what I'm going to do is I'm going to figure out what coefficient I can put in front of the compound to change the 1 O to 2 O's. All I'm going to do is, since this is on the right side, I'm simply just going to multiply this 1 by 2, which means I'm just going to put a coefficient of 2 in front of this H2O because that's our only place that has an oxygen. So that's why we're putting the coefficient in front of H2O. Now remember, a coefficient multiplies out to each element, not just one, since they're in a compound. So that 2 multiplies to the H2. So the H2 is now 2H2. And since this H has a subscript of 2, this H has a subscript of 2, this 2 multiplied by the 2 subscript is actually going to tell us that there are now 4 H's on the right side. And then again, we'll look at our O. This 2 has multiplied to the O, telling us that there are now 2 O's on the right. I'm going to erase these arrows now. And hopefully this is a little more clear, but now we see that our O's are in fact balanced now. And so are our Mg's. We didn't really even have to do anything to those. Now let's look at our Brs on the left side because we see on the right that we have 2, but on our left side, we only have 1. And it is easy to go from 1 to 2. So what can we do to get that 1 to be a 2? we simply put a coefficient in front of our HBr so that it can multiply out to the H and the Br to give us 2 BRs, because remember, the 2 is multiplied by the BR that has no subscript, so it's just 1 times 2, which is 2. Our BRs are now balanced, and our H, that business is going to be a little different. The 2 multiplied out to this H, which had no subscript, so that means that there are 2 H's here. But don't forget that we also had an H in this OH compound that was being multiplied by a 2. So there are also 2 H's here, thanks to our 2 that multiplied out to this H in this compound. So 2 H's plus 2 H's actually now gives us 4 H's on the left side. So I'm going to erase all of these random arrows just so everything's a little more clearer. If we look now, everything is balanced. There are 4 H's on the left, 4 on the right. We have 2 BRs on the left, 2 on the right, 1 Mg on the left, 1 Mg on the right, and 2 O's on the left and 2 O's on the right. So everything is balanced, everybody's happy, and this chemical equation is satisfied. Now notice that these elements don't have a coefficient in front, or at least they look like they don't. When you have this, you can simply leave it as is and leave it blank, or you can write a 1 in front of each compound. And that's it for this problem.